So let's begin with today's session. So welcome everyone to the NPTEL course on the novel technologies for food processing and shelf life extension. This course is instructed by Professor H.N. Mishra, Department of Agriculture, Food Engineering in the IIT Kharagpur, and I am Shikha Sharma, Research Scholar in the Department of Chemical Engineering, IIT Guwahati. I am the teaching assistant for this course for January 2025 semester. And this is a live interaction session for the week 4, which is having topics including food irradiation, radio frequency, and microwave heating, supercritical fluid extraction. I hope you have all gone through the 5 lecture videos regarding this topic. And in this session, we will be solving some of the practice problems related to these week 4 topics. And if you have any doubt, please feel free to ask. Okay, so these are the today's topic. We will be discussing about food irradiation, microwave heating, radio frequency drying, and then supercritical fluid extraction. So first practice problem is about which of the following options are examples of particulate radiation. So we have these 4 options: gamma rays, X-rays, electrons and protons, and fourth is alpha particles. So which is the example of particulate radiations? So what is particulate radiation and which is the particulate radiation? So please try to answer. Anyone?
B.
C option, which is 3 and 4. So first, what is particulate radiation? Can you please share with us? So please, what is particulate radiation? Anyone of us would like to share the opinion? So let's discuss. Yes, option B is correct. So what are like we have 2 types of radiations, electromagnetic radiations and the particulate radiations. The electromagnetic radiation, they consist of the photons basically, which is having energies. These photons are having energies, but no mass or charge, such as the radio waves, microwaves, infrared, visible light, ultraviolet rays, X-rays, gamma rays, etc. A photon, as described by quantum theory, is a particle or the quantum of the energy that contains discrete quantity of electromagnetic energy which travels at a speed of light. So we have in the electromagnetic radiations, we have photons which are having the electromagnetic energy, and they travels with the speed of light and they transmit the light, but they don't have any mass and charge. But in the case of particulate radiation, what happens? These are consisting of the particles that have mass and energy, and they may or may not have any electric charge, such as the alpha radiation, beta radiation, proton radiations, and the neutron radiations. Particular radiations, they are basically electron, it includes electron, protons, neutrons, and alpha particles. So as they are having mass and charge, and they don't like uh, Sometimes they don't have any electrical charge, but they have the mass and energy for sure. And they are like the particles, consist of the particles. This is the difference between the electromagnetic and the particulate radiations. So we can see it's the electromagnetic spectrum. So we have many radiations like we can see here, and their respective frequencies and the wavelengths are also given. So what happens, like this is the nucleus of the atom. So from this, what happened, alpha radiations comes out, which are basically like uh, having the two protons and two neutrons. There are gamma radiations come out from the decay of a radioactive particle. So what happens, high energy electromagnetic photons, they will come out, and that is gamma radiation. And third is beta radiations, which is high energy electrons. So when a nucleus of an atom, it decays, so there are these kind of radiations like the alpha, beta, and the gamma radiations, they come out. So we have option B, which is having 3 and 4, which means that particulate radiation includes electrons and protons, also alpha particles, which is true. We can see here like it is electron, proton, and alpha particles, and they are included in the particulate radiation. So option B is correct here. Is it okay?
Okay.
Yes, ma'am.
Okay,
Yes,
so
ma'am.
thank
Yes,
you.
ma'am.
So thank you. So we are moving to the next question, which is identify the options showing the correct descending order of the different type of radiations in the frequency spectrum. So we have gamma rays, UV light, infrared, and microwave. And we need to arrange them in the correct descending order of in terms of their frequency. Please, uh, anyone? We have just now saw this electromagnetic spectrum. Anyone would like to try
A.
this B option? So
A.
A is correct, yes. Actually, as per the electromagnetic spectrum, if we see first, like highest is the gamma radiation, which is having here this location around 10 to the power 20 hertz. And then we have ultraviolet light right here, and then infrared is here, and microwave is at the last. So if uh, it's placed in the electromagnetic spectrum more this side, like more left hand side, so it means more frequency and lesser is the wavelength, because they are inversely proportional. So here gamma rays is having the highest frequency and microwave is having the lowest. So option A is correct. Is it okay?
Yes, ma'am.
Okay. Let's move to the next question. So yes, as per the explanation, the gamma rays frequency is around 10 to the power 20 hertz, whereas UV light, it is having the frequency higher than the like visible light. We have two UV vis. So UV means UV comes first and then visible light comes, right? So frequency of this is 10 to the power 16 to 10 to the power 14 hertz. Infrared light we have, and its electromagnetic radiation is between the microwave and the visible light. Like we can see, it's between microwave here and visible is infrared. So it's in between, and it sometimes classify into three spectra. Like it is divided into three types: near infrared, short infrared, mid range, and four types. We consider near, mid, and long, but here it is given like fourth type, which is short also. So these are the its wavelengths, and the frequency of infrared light is around 10 to the power 11 to 10 to the power 14 hertz, and the frequency of the microwave is 10 to the power 8 to 10 to the power 11 hertz. So these are the wavelengths of different radiations given in the table. So we can see in the diagram on the right that the penetration. How is the penetration? So alpha particles, they will not gonna penetrate paper also, but beta particles, they can penetrate paper but not aluminum. But the gamma rays, since its frequency is very high, so it even penetrates aluminum but not the lead. So higher will be the frequency, means more penetration it can do, the more like it can penetrate to uh, like different substances or different materials. So this is our next question, which is like column 1. So it is having the irradiation effect on the living organism, which are lethal to insects, lethal to human beings, sterilization of microorganism, and sprouting inhibition. And in the column 2, there are the dose of the radiation given. So we need to match like which dose of radiation can be lethal to insects or humans, or can inhibit sprouting, or can do the sterilization of microorganisms. So let's discuss what happens. The option C is correct. Let's see why. The dose of radiation which is required for the lethality of insects is around 10 to the power 3 to 10 to the power 5 radiations. So what happened? Radians. So what happened? Um like if we give 10 to the power 3 to 10 to the power 5 dose of the radiation, so what will going to happen? Insects will be die, and around 10 to the power 2 to 3 it is lethal to human beings. For microorganism sterilization, the dose of radiation is very high, which is around 10 to the power 3 to 10 to the power 7. And for inhibition of the sprouting, we have a range of 10 to the power 2 to 10 to the power 4 dose of radiations. So we have this option C is correct, which is saying that the lethal to insects is 3 to 5, 10 to the power 3 to 5. For humans, it's even lesser. And for sterilization of the microorganism, it is like more, because we are doing sterilization. And for inhibition of sprouting, we need this much of the dose of the radiations. So we can see in the picture, we give around like this first picture is saying that that the insect is dying. It's lethal to insects. Sometimes if we give around 800 um, gray of the radiation. And some like for human beings, there are like different it's like different exposure levels. Like, is it in the tolerance level or moderate level or at the higher risk? So it can affect eyes, lungs, stomach, skin, many things. Like it affects in the human beings, so it may be lethal to human beings as well. In the third figure, it is showing that how X-rays from cobalt, it is coming and it is uh, affecting the like sterilizing the microorganism. Like it's not just X-ray, many rays can come. So cobalt 60 is used as a source to produce the radiations, and it is affecting the DNA of the microorganisms for sterilization purpose. And in the last figure, we can see that we are treating potatoes so that the sprouting can be inhibited like by the help of the radiation treatment. So I hope it's clear. This question is clear to everyone.
Yes, ma'am.
Yes, ma'am.
Okay. So we are moving to the next question.
Yes, yes.
Okay. So which of the following microorganism is the most resistant to irradiation? These we have four microorganisms and we need to tell up their resistant towards irradiation. So we need to first find the category, which category they belong. So it will be easy for us to spot, to identify like which one is more resistant.
Ma'am B. Option B, ma'am.
Clostridium
B.
botulinum.
Option
Okay.
B, ma'am.
Clostridium botulinum.
Many people are saying Clostridium botulinum.
Ma'am,
Any
option
other
B.
option? Yes, option B. Okay. Any other option? Anyone would like to contribute to any other option? Okay, let's discuss the solution. It's option C, not B. Let's see why. Because the radio resistance, which is level of ionizing radiation that microorganisms are able to withstand. So the radio resistance level in the yeast are the maximum. So after that, it's molds, then gram positive bacteria, and least will be for the gram negative bacteria. So since option C is a yeast, so our option C is correct. Basically, yeasts and the molds are generally they are more resistant towards irradiation than any of the vegetative bacterial cells. And bacterial spores are more resistant than the vegetative cells of the bacteria or the yeast or the molds. And viruses are even more resistant towards the irradiation. So this is our sequence. What happens in the yeast? The yeast are the eukaryotic single-celled microorganisms. So what happens? They have effective DNA repair system. So when irradiation is coming and affecting the like irradiation is coming and affecting this yeast, so what happens since it is eukaryotic organism, so it has like complex system of function. So what happens? DNA it has its like a robust DNA repair system. So irradiation, if it's coming and affecting the DNA, so it fastly repairs, and its cell wall is having chitin and beta glucan, which can protect its cell wall. and lesser of the radiation can come inside and affect the DNA. Also, it has antioxidants like these two antioxidants. It has what these antioxidants do, like they neutralize the reactive oxygen species. So when irradiation is coming and forming the reactive oxygen species, so these antioxidants they neutralize it. So in protecting from the irradiation. Also, it can also go in the dormant state. Yeast and it can easily go compared to molds. Molds they are having the filamentous structure which are known as hyphae. So because of that, uh, since it is having its different structure, so it's like more open compared to the yeast, which is mostly the spherical or the oval shaped structure. So it is more like the more radiation can come towards it because it has a different structure and affect it. So yeast is the most resistant than the molds, and gram positive then the bacteria. And in bacteria, gram positive, since it is having thicker peptidoglycan layer, and we can see in the diagram it has thicker peptidoglycan layer. And in the gram negative bacteria, the peptidoglycan layer is very like it's just 1 to 5 layers. So it is more sensitive towards the irradiation compared to gram positive. Yes. So gram positive bacteria is more resistant. So our option C is correct because it's a yeast. Uh, After C, it's our Aspergillus niger, which is a mold, and then Clostridium botulinum, which is a gram positive, and at the end, Campylobacteria jejuni. Okay, is it okay for everyone?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yes.
Okay. So let's move to the next question for today's. Which of the following is the correct order of food components with respect to the irradiation sensitivity? So now it's the irradiation sensitivity towards the food components like water, lipids, and proteins. So we need to tell like which components is having the most sensitivity and which is least.
A.
A. So
Option A.
option yes. So we are correcting option A. Water, then lipids, then proteins. Anyone else?
Ma'am, option B.
Okay. So
B, ma'am.
next is option B. Water, protein, and then least is the lipids. Anyone else?
B, ma'am.
So yes, actually option B is correct. So let's see why B is correct and A not correct, and others also. So what happens? Uh, Usually the order is water, then protein, and including the nitrogenous compounds, and least is the lipids and fats. So what happens in the water? Water goes for the radiolysis, which means that it goes in the series of the phenomena by which molecules are destabilized by ionizing radiation particles such as the pho- photons, electrons, heavy ions, leading to new chemical species. So water, it goes under the radiolysis, this phenomena, and it produces the oxidizing agents like these, and also reducing species like these it forms. And because it produces these oxidizing and reducing species, these will going to interact with the food components like lipids, and lipid can go under lipid peroxidation, and it can it can contribute indirectly to the protein denaturation, because it's a, like it forms free radical species. And because of these presence of these oxidizing and reducing agents, the oxidation of the flavor compounds or other volatile compounds or other compounds can also happen. So this is the chemical reaction. This water, what happens, it goes radiolysis and it forms solvated electrons, and it forms OH free radical H, then it forms hydrated protons H2 and H2O2 it forms. This includes it includes free radicals, and it includes this solvated electrons. So these will going to affect the other compounds, like it affects proteins also. Like what happens, proteins and amino acid, it can react with the primary free radicals, which is generated from the radiolysis of water. So radiolysis of water, because if any food it is having water, if we take any of the food, it is having water. So if water goes in the process of radiolysis, it generates free radicals, and because of the generation of the free radicals, proteins and amino acids can react, and the reaction of the solvated electrons with proteins, it leads to deamination and scission of the peptides and disulfide bonds in the protein, and then it forms variety of the radiolytic chemicals which are present in the irradiated foods. And the reaction with OH radicals with the proteins, it leads to H free radical formation, H free radical abstraction, and there will be addition to aromatic and sulfur containing amino acids residue. So which leads to consequently formation of the oxidative compounds of these proteins. Like we can see on the right side, there is a reaction given, like methionine is a amino acid. It goes it reacts with the solvated electron, and it forms uh, dimethyl sulfides, dimethyl trisulfides, dimethyl sulfides, dimethyl disulfides. These compounds, sulfide compounds it forms, and these sulfide compounds, they will going to give sometimes there is a term known as irradiated order, which means that because of the irradiation, these amino acids, they the methionine, it converts into the sulfide compounds, and these sulfide compounds, they will going to uh, produce some kind of the order which can be desirable and undesirable. Sometimes when we irradiate food, metallic uh, kind of order, it comes out from the food product. So it's because of several formation of the several compounds. Like what happens if we talk about the frozen food systems, the OH radical, its contribution is generally decreased. In the when we talk about the frozen system, it is little less sensitive towards it, because OH radical, its contribution decreased, and the radiolytic products from the protein are reduced in the frozen state. So it's good to irradiate frozen system. Irradiation of protein, it results in the deamination, decarboxylation, reduction of the disulfide linkages, oxidation of the sulfhydryl groups, modification of amino acids, peptide chain cleavage, and the aggregation. So it affects protein after that. So most is affected, like because water is mostly present and in the highest amount it presents. So like water is the most affected compound. After that, the protein, and least is the lipid. So what happens? Lipids like fatty acids, when they irradiate, there is a cleavage of cleavage occur near the carbonyl bond. Like we can see in the figure, like this cleavage near the carbonyl bond occurs. And majorly radiolytic products of the fatty acids, if we talk about in the absence of oxygen, there will be carbon dioxide, carbon monoxide, hydrogen, hydrocarbons, aldehydes. In the like if there is oxygen, maybe ketones may form. And because like one example it's given that like because of the production of the carbon monoxide, there can be development of the redness in the meat. So that is an undesirable change happens. Also because of the radiolysis of the lipids, or the oxidation of the lipids, trans fat sometimes can form. And because of the like maybe like sometimes it happen, if some compound, like it's like some food component food substance is not having any trans fat, and it may also happen that because of the irradiation, trans fats may develop, and it will not going to be like during it's like development of the trans fat during the processing of the food. So it is not good. The trans fats, we all know that it's not good. So it's the for like because of irradiation, these undesirable changes also may occur. So our option B is correct. Is it okay?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Can you understand? Can you relate what are different changes happen to like water, protein, and lipids? Because it's important, like to understand. Are you able to understand these in these details?
Yes,
Hello,
ma'am.
ma'am.
Okay, okay,
Hello,
okay.
ma'am.
Yes,
Hello,
yes,
ma'am.
yes.
Yes, ma'am. Yes, ma'am.
What
Yes.
is irradiation?
Irradiation is when we are giving food, like irradiation is a process where we give radiation. Radiation means when we are giving like the gamma rays, X-rays, we are irradiating, we are giving some kind of energy or the photons to to any substance, to any particle, to any food, like food we are here talking about, like food. So it includes like all these are different gamma rays like we are giving to any food. If you talk about all these are irradiation, be it electromagnetic radiation. So irradiation is just a process of giving radiation. So these are radiations which we are giving, and it can be like photons with no mass and charge. It can be any particle which has the mass and charge but have no electric charge. So all these like alpha radiations, beta, gamma, all these are radiations.
Okay, ma'am.
Okay. Is it clear?
Yes, ma'am. Hello, ma'am.
Yes, ma'am.
Yes, yes,
ma'am,
please.
पता नहीं मुझे स्लाइड आपकी सोनी हो रही है जिसपे क्वेश्चन गिवन होते हैं.
शो नहीं हो रही है. Is it my screen is visible to everyone? My slides are visible to everyone. Is it okay?
Yes, ma'am.
Yes, ma'am.
Yes, visible.
It's visible for everyone. Please, can you check in your system? Are you able to solve? Are you able to solve the problem?
No, ma'am.
Is it visible now for you?
Yes, ma'am.
Okay. So let's move to our this question. Which of the following purposes need medium dose of irradiation? Delaying ripening of the fruits, decontamination of herbs and the spices, and third is disinfestation of the stored cereals and pulses, and fourth is the reduction of spoilage microorganisms in the fish and poultry. So
Ma'am,
we
number
have, yes,
4.
which one?
Ma'am, D. C. Ma'am, D.
Okay, we have two options,
C.
B and C.
Yes,
C, ma'am.
C, ma'am.
Ma'am, C.
Please, please, can you, if you are discussing something, please can you mute? Like, okay. So we have two options, C and D. Anyone else?
Ma'am, C.
We have more votes to C. So we have three type of the doses in irradiation: low, medium, and high. Right? So our option C is correct, which is medium dose of irradiation means decontamination of herbs and spices. And option D, fourth is reduction of the spoilage microbes in the fish and poultry. So we have low dose of the application, which includes less than 2 kilogram, which is useful for, please can you mute? Please can you mute? Okay, thank you. So low dose of the application is for it's less than 2 kg, and it is for sprouting inhibition, delaying the ripening, disinfestation of the stored cereals and the pulses. For medium dose application, we have a dose between 1 to 10 kg, where there is a reduction of the spoilage microbes in the fish and the poultry, decontamination of herbs and spices, reduction in the level of the pathogenic microorganisms, and like the similar to the pasteurization, till the level of the pasteurization. Third is high dose application, where there is a dose greater than 10 kg is applied for the purpose of sterilization. So medium dose is for decontamination of herbs and the spices and reduction of spoilage microbes in fish and poultry. Is it clear why we have no
Yes.
option D? D is not correct here. C is correct, right? Let's see this question, which is about load like different type of the irradiation process, where like we have which of the following refers to a low dose radiation pasteurization treatment, but where there is specific intent of elimination of a particular pathogen. So we have these four options: redapterization, reduration, radiation, and A and B both. So please, have you learned about it? Like these terms, are you familiar?
No, ma'am.
You have not listened to the lectures before this class,
B.
because it's there in the lecture videos. You must go through the lecture videos before joining this class, because it's a practice problem solving. So if you have already gone through, you have a better understanding what is happening in the lecture.
Option
So
C, ma'am.
we got B, C,
C.
and D.
D.
Three options we got, right? B. Let's see. Option C is correct. Redapterization is a term which is used for radiation sterilization. It's a sterilization where high dose treatments, they are being applied to get a product which is shelf stable. And redurization is basically a radiation pasteurization. So it's a pasteurization, but low, and it's a low dose treatment compared to the first one. And here is in like the, because here intent is important, right? So here intent is to extend the product shelf life, but in the recidation sorry, radicidation, so what happens, low dose is also like in the case, as in the case of B, same low dose is being applied, and it is also a radiation pasteurization similar to this second one. But what is happening, specific intent is here to eliminate the particular pathogen. So option C is correct, not B, because intent is important, for which purpose we are applying the radiation. Is it clear?
Yes, ma'am.
Okay.
Yes.
So we are moving to the next question, which is about the packaging of in which we pack our radiated food. So, which of the following packaging material can withstand the maximum dose of irradiation? So, it is PVC, polystyrene, polypropylene, and polyethylene (PE).
Ma'am, option B,
B.
styrene.
Polystyrene, maximum dose of
Yes.
irradiation.
Ma'am, option A.
Option B is correct. As we can see, polystyrene is like the one which actually can tolerate the maximum dose. So PVC, it can tolerate around 100 kilogram. Polystyrene, it can tolerate around 5,000 kilogram. PP, polypropylene, it is having 25 kilogram tolerance, and PE is having 1,000 kilogram. So option B is correct because it is having 5,000 kilogram. We mostly have like we can have two types of the foods. Like first one is the like we are uh, irradiating a food product first. Irradiation is happening, and then we are packing the food product. So that doesn't need that much of resistance. But we have when we have pre-packed food, uh, so in that we need um, kind of resistance towards the irradiation in the packaging material, or it can tolerate at least that dose without going any chemical change. So like as per the guidelines, gamma rays, electron beam, and X-rays can be used to treat pre-packed foods and up to a dose of 10 kilogram. It is as per the guidelines. So what happens? Food packaging materials, they mostly are composed of the different kind of the polymers, like polypropylene means it's a polymer of propylene. Polyvinyl chloride, so it's a polymer of vinyl chloride as a monomer. So most of the packaging material, they are made from the polymers, and they are susceptible to different chemical changes which can be induced by ionizing radiation. That are the result, like we can have two reactions, like polymer cross linking can happen, and chain session, or the chain may degrade. It can also happen when like the ionizing radiation is hitting the packaging material. So radiation induced cross linking of the polymers, it dominates under vacuum or the inert atmosphere, whereas chain scission dominates when the irradiation of the polymer is in the presence of the oxygen or the air. So these type of undesirable changes may happen to the packaging material. In the presence of the oxygen atmosphere, radiation induced degradation of both the base polymer and adjuvants, it can happen, like such as the antioxidants or the stabilizers, like base polymer and the other additives we add for making films, or the like we are polymeric films for packaging. So like it may include antioxidants or the different stabilizers. It can like the both can undergo the uh, like it can degrade and it can form radiolytic products different, like after degradation there it can, after degradation because of the radiation, it forms radiolytic products. So these products, they uh, may be present at significant levels, and these radiolytic products even can migrate into the food product. It can, it can affect the odor, it can affect the taste. Yes, I'm sorry, the camera is switching off. So yeah, it can affect the odor, it can affect the taste, and therefore it can affect the quality of our irradiated food. Like for example, certain additives, they are prone to the degradation when the polymer is like processing, and because of that during irradiation they would be expected to degrade faster or preferentially over the polymers, and because they are already unstable, so when the irradiation will come, these additives, they will degrade and they will form some radiolytic products, and because, and these products, they can migrate into the food products, and because of that our food may get, its quality may get affected, and its safety can also be affected. So these, uh, because of the degradation in the packaging, we must consider in which packaging we are putting the food when, while we are irradiating. So mostly we should put in polystyrene containers or polystyrene bottles to save, to like save the formation of the radiolytic products. Is it clear?
Yes, ma'am.
Yes, ma'am.
Thank you. Thank you. So we can move to our next question now, which is, in which state of food the radiation causes minimal chemical and flavor change? Liquid state, frozen state, solid state, or the paste form? This answer I'm expecting from you, because we have just now, like before few slides, we discussed about it.
B,
Frozen.
frozen state.
Frozen state, right?
Frozen state.
Because in the frozen state, the radio sensitivity of the microorganism, they will reduce, of the different food components, the sensitivity is also going to reduce. So the sterilization, when we are doing in the frozen food, it changes minimal chemical and the flavor changes. So we need, for sterilization, like if we are doing for the frozen food, we need greater dose for killing of the microorganism, because in the frozen state the sensitivity of um, the different organisms and even the food components, it goes down, right? So let's, we are doing so much of the conceptual questions, let's now solve one small problem. Please try to solve this. The D10 for Listeria monocytogenes in meat is 0.7 kilogray. Calculate the radiation dose in the kilogray needed to reduce the Listeria count by 9 log cycles. So we have two things are given, that we have this dose of the radiation and we have the reduction value, which is 9 log cycle, count is reducing. We need to calculate here radiation dose. D10 value is at which dose? Okay, so let's solve this question. We have D10 value as 0.7 and like at 1 log cycle reduction is at 0.7. That means, right, D10 value means we discussed in the previous lectures, previous live sessions, that D10 value is 1 log cycle reduction, right? So this value is 0.7 and we have already given that we are going through a 9 log cycle reduction. So we are reducing the count, the log n naught by n, which is from the like n naught is the initial count of the microorganism, n is a final count which is given as that 9 log cycle reducing, right? So log reduction in microbial population is equals to log n by n naught equals to minus dose divided by d10. So it is given already 9. So we will take minus 9 because log log n by n naught value we need to take. Here its log n by n naught value is given. So log n by n naught is minus 9 is equals to dose divided by d10 value. So dose is 9 into d10 value is already given in the question as 0.7. So we need a dose of around 6.3 kilogram. Is this question clear? How we solved it?
मैम
Yes.
तो क्वेश्चन क्लियर है। मैम नेक्स्ट लास्ट संडे ना आपने क्वेश्चन कराया था फॉर जूस 10% में फीड फ्लो बताना था कैलकुलेट करके। मैम सेम क्वेश्चन ना हमारा असाइनमेंट में भी सॉल्व करना आया था, तो जो
Okay.
आप को टिक किया बट जब उनके आंसर आए तो वो आंसर बोला
आंसर नहीं मिला।
इनकरेक्ट, मतलब जो
आंसर
आपने बताया आंसर हमने क्या था, लेकिन उनके आंसर आने के बाद ना जो वो आंसर जो आपने बताया था वो इनकरेक्ट उन्होंने शो किया।
can you is it a numerical problem? Can you show me like which let me see. Which week?
मैम लास्ट टू लास्ट।
Let me see. Last to last means week 2.
यस मैम।
Yes. 2nd February.
Let me see. Some week 2. Which question?
मैम फॉर जूस ये शायद लास्ट का स्टार्टिंग फ्रॉम फॉर जूस।
Is it vitamin C one?
नो मैम ये नहीं है, नो मैम ये भी नहीं है।
Juice. No.
मैम वीक 3 का क्वेश्चन है।
Week 3 का? Okay.
सॉरी हो सकता है, सॉरी
वीक 3 का क्वेश्चन है मैम। कैंसिल दिखाया है, मतलब रिजेक्ट
Which
दिखाया है।
question? Yeah. Which question? Is this the question?
Yes, ma'am.
Ma'am,
Yes, ma'am.
Okay. So what is the exact problem? Can you share now?
मैम वो आंसर गलत दिखाया है मैम. आपने जो आंसर दिया था वो आंसर गलत दिखाया है.
अच्छा. तो क्या आंसर दिखा रहा है? Which option they are showing it, the correct one?
आंसर मे बी मैम बी या सी था इन लोगों का.
0.5.
0.5.
30.5 to 31.
हाँ,
Option
yes,
D.
yes, yes, yes,
Option D.
yes,
Okay.
yes,
Yes.
So because answer this we have all like solved it. So obviously this is only correct. So I am noting it down and I will discuss it. Okay.
Hmm.
Because if you solve, have you and any of you have solved it by yourself? Tried to solve it. Is it the same
And
answer?
ma'am,
Yes, yes.
and ma'am,
If you
no.
are solving, so value will be 33.5 approx.
Yeah. So when we solve it, answer will also be the same, right? Because
Yes,
I have
correct.
also solved. Yeah, because I have also
Yes.
solved it
Yes, ma'am.
before. Yeah. So I will discuss this question. Week 3. Okay. So I will discuss. I think they have given it as a like maybe there is some problem because I am able to see the next assignments are also having some or other issues, right? Minor mistakes.
मैम एक प्रॉब्लम और है.
Yes,
मैम क्वेश्चंस आते हैं ना, अगर हम उनको गूगल पे सर्च करें तो वो आंसर करेक्ट होते हैं, लेकिन जब ये अपना आंसर देते हैं तो वो हमारे इनकरेक्ट होते हैं. हमारा लॉजिक भी ठीक होता है जो हम करेक्ट करते हैं, फिर भी आई डोंट नो कहाँ पे एरर है फिर.
that's what I'm saying. That some like some assignments questions are having like minor differences. So more like if Google is saying even like I think that is more correct. If you are solving and like this question, if you are solving and getting the answer, that is obviously the correct. So when we are going through like the assignments and everyone's answer will be different, like the give as per the solution. So obviously that time we will look why this is happening, so and then it can be taken into the consideration. Okay.
Ma'am, there was one
Yeah.
more question in week 3, and
Okay.
assignment question number is question 9, which
Week
says
three.
which of the, yeah,
Okay. Week 3, 9. Is it
uh,
included in my slides or is it
no,
or
no, the direct question is not included in the slide, but we have discussed the concept like HP treated sausages are less cohesive and less
Mhm.
firm than heat treated sausages.
Okay,
So
okay, that
this was asked in one of the assignment questions, like choose which statement is true. So here they have mentioned the statement is HP treated sausages are less cohesive and more firm than heat treated sausages, which is
Mhm.
incorrect.
Yeah, true.
So
Even the slides are Professor Mishra's lectures are also like the same, right? Saying that it's
yeah, so they are also this question also has some problem. Like I have selected the right answer, but it says it's incorrect, and it's
true,
showing
true,
like
true.
it's true. Yeah. So we
Yes,
have
yes,
two problems with the week 3 assignments, like question number 9 and another is question number 11. Yeah.
question number 9 and 11. Okay.
Yeah.
So yeah, same because I have also seen that you guys do like put all your queries in discussion forum. So please put these
Mhm.
questions also in discussion forum. Yeah, obviously I will
Okay.
going to talk. Yeah, I will going to also discuss why it's happening.
Mhm.
But you also because if it's there in discussion forum, it's easy to go through any time that which questions you guys are having problem. So there we can see at any time. So please put these type of question like queries also in discussion forum, because if you will not put, we cannot see, right? And this question which you are talking about right now, I have already seen in that it's there in the discussion form forum, where this you are saying that HPP question. So we are seeing the your messages, don't worry, and we are considering that. So
Okay, ma'am.
you
Thank
can,
you.
yeah, you can put there, no problem. So you just can post uh, whenever you face, even in future, if you face such kind of issues, please post so that we can consider. So okay. So, can we restart our where we left our discussion?
Yes, ma'am.
Okay. So, yes, this question we were solving, and I was asking if it's clear. We can move to the next question.
Yes,
Yeah.
ma'am.
Okay. So let's discuss about X-rays. So, which of the following statement is are not true for X-rays? So, first is X-ray induce strong radioactivity in foods. Second, a beam of electrons is directed at a thin plate of gold or other metal, which produces a stream of X-rays. Third, like gamma rays, X-ray can pass through thick food products and require heavy shielding for safety. Fourth is X-rays are usually more energetic than gamma rays. Not true for the X-rays.
मैम ये डी आई थिंक
Okay.
ऑप्शन डी
So
D.
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 We have two D.
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 B. We have both D and one is B. So let's see.
Madam,
D is correct. Yes. So option D is correct. So what happens? Gamma rays are the one which induces the strong activity in the food. Why? Because it is having the highest frequency. So it is the one which is having highest, strongest radioactivity in the food, not the X-ray. So it is incorrect. This option is not correct. Option then a beam of electrons is directed at a plate of gold or other metals, which produces the stream of X-rays. Like we can see, this is the system for producing X-ray. Here what happens, there is the cathode. Here is a power supply which is going towards the cathode, and then here, because there is this potential difference, because there is a cathode and anode, so electrons are here producing and going from cathode towards anode. Anode is our copper anode, where these electrons are going, and with a high speed, and they are going and striking on, like striking to the copper, and because of the very high speed striking of electrons, the X-rays here produces. So there is mostly we use copper, but sometimes we use gold and other metals also to produce X-ray. So it's this second option is correct. Third option is saying like gamma rays, X-ray can pass through thick foods and require heavy shielding for safety. Because X-ray is also, if we see the electromagnetic spectra, X-rays and the gamma rays, they are near, right? So mostly it can also be able to penetrate, and that's why it can penetrate to thick foods. And uh, because it penetrates, we need, when we are treating, we need the shielding high for our safety. So this option is also correct. Last is the X-rays are usually less energetic than gamma rays. But here it's saying more energetic. So this option is not correct. So our option D is correct, not B, because these two are correct one. But these, it is saying not true. Okay, is it okay? Or
Yes, ma'am.
Yes.
yeah. So
Yes.
please, please put all your assignment queries where your questions are not matching. Please put on the discussion forum. It's easy to go through, right? So
Okay, ma'am.
all, yeah, because obviously it will be resolved and the correct options will be considered only. Okay. So we are moving to the now second topic, which is microwave heating. This is the system for the microwave heating. So we need to mark these 1, 2, 3, 4. These parts, like machine parts, which are there. So which one is the mode stirrer?
D.
Magnetron. Okay, D.
D.
Wave.
Ma'am,
D.
D.
A,
D. Option D. Ma'am, D.
Option A.
We have two options, A and D.
D.
Okay, please try to tell me the logic, like what each part is doing. What is the function of oven cavity? This is the like what oven.
Ma'am,
Yes.
ma'am, option A is correct because uh,
Hmm.
first option is more stirrer. It means like a hold something.
Okay.
And second is magnetron tube.
Hmm.
In which waveguide is attached, and option 4 is oven cavity, where is the radiations act.
Okay.
It is the inner part of the
Hmm.
oven.
Hmm. Hmm.
That's why, ma'am, option A.
Okay. Anyone else would like to also tell us, or is she correct?
No, it's D.
No. Ma'am.
Oven cavity is where we place our food, and
Right.
magnetron tube generates the microwaves, and waveguide gives the path for microwaves, and mode
Hmm.
stirrer is for just it's a junction between the waveguide and where the food is placed. Yeah,
Okay.
I
Okay.
can't recall the right. Uh, okay.
Okay. So she also explained her opinion. Anyone also would like to add, or is she correct? Both of, like who is correct?
D
Option
is
B.
correct, ma'am.
Option B. Who someone was saying, why option B is correct? Is this magnetron? So yes, option D is correct. She was correct. Why? Let's see what happens. This is the oven cavity where we, as she rightly mentioned, both of them rightly mentioned actually, that where we place our food, it's the oven cavity. But here it's like maybe little mistake regarding waveguide and magnetron. Magnetron is this one which produces the like waves or the radiation it produce, microwaves it produce. Waveguide is the one which guides the microwave towards this, and mode stirrer's function is basically it uh, it like it's actually kind of a like it not I'll not say that it will direct, because waveguide is directing, but whatever the waves already came into this uh, place, it like alters the pattern of the electromagnetic wave. So what happens, like whatever is in the cavity of the this oven cavity, whatever this these waves are already there here, these all waves, it alters its pattern. So what happens, it's like kind of a stirring action, it, because its name is mode stirrer. So what it do, it's kind of a stirring action it is doing for the microwave. uh, so for the waves itself, it is doing the stirring action, so that evenly heating can occur, and there is no kind of like the formation of the hot spots or the cold spots. So if there is uneven kind of heating, there may formation, like some place may be, sorry, some place may be uh, like heated well in the food, and some places like this place may the core may not heat well. So to divide this waves uniformly around the food product, we need these kind of the stirrers. Like mainly it's because to maintain the uniformity. Also, what happens when the waves is there and it is going like this, so it reflects also. So all the waves it like it directs, it gives the like the direction it gives, so that they can form kind of the uniform uh, wave pattern in whole of the cavity. So this is the function of mode stirrer. So okay, is it clear why we have option D? Because this is the guide. Option A is saying this is magnetron tube, but it is guide. Here our waves produces and it guides, and here it comes in the oven cavity. Is it okay?
Yes, ma'am.
Yes, ma'am.
Mm,
Yes, ma'am.
yes, yes, okay. So let's solve one problem about the penetration depth. So when there is a microwave, we have the concept of how much it can penetrate into the food product. So what is the penetration depth in the meters when there is microwave emitted at a frequency of 2450 megahertz in the raw potato, which have the dielectric constant 67, loss tangent 0.234, and speed of the wave is 3 into 10 to the power 8 meter per second. So it's the simple formula we need to apply. Please try to solve. Anyone would like to tell what is the formula for penetration depth? It's already like discussed in the lecture videos, what like the formula for penetration depth.
Ma'am, it's lambda by 2 pi and square root of dielectric constant and loss tangent.
True. So we have this formula, penetration depth. Lambda, which is the wavelength, divided by 2 pi under root E dash by 10, E dash then loss tangent. So this is dielectric constant and this is loss tangent, right? But in this, what we do not have, which value we do not have, and which we have. Let's see. So given value, dielectric constant is given as 67 already. Loss tangent value is also given as 0.234, right? We have these two values given. And then we don't have the value of lambda here as per the formula. So how to calculate lambda? Lambda means wavelength equals to speed of the wave or then divide by its frequency. But here in the question it is said that the speed of the wave is similar to the light, which is 3 into 10 to the power 8 meter per second. So this is the speed of the wave. Frequency we have given as 2450 megahertz. So for converting into the hertz, we are multiplying with 10 to the power 6. So speed of light 3 into 10 to the power 8 divided by the frequency in hertz 2450 into 10 to the power 6. When we divide, answer will be this 0.122 meter. This is our lambda. So now from this we can calculate penetration depth as lambda equals to 0.122 divided by 2 pi under root dielectric constant, which is 67, and loss tangent as 0.234. So the answer is this. When we solve, pi is 3.14 value. So please everyone solve this and see if 4.9 into 10 to the power minus 3 meter is coming or not. So this is the diagram depicting what happens. Microwave radiation, it comes to the food, and the food like this is the penetration depth. So it penetrates to some depth. Where there is it penetrate, it is more hot, and at the core, because if it's not able to penetrate, it becomes little cold. Is it please can you verify if we are getting the same answer?
Yes, ma'am. It's coming.
Okay, so she has already verified that 4.9 into 10 to the power minus 3 meter. So our option A is correct. Is it clear to everyone? Can we move to next question?
Yes, ma'am.
Okay, let's go to next question. The ratio of thermal conductivity to the product's volumetric heat capacity is defined as dielectric loss factor, dielectric constant, or is it thermal diffusivity, or is it temperature gradient? So this is the definition.
Thermal diffusivity.
Thermal diffusivity. Agreeing to her? Are we all on the same thing, same option?
Yes, ma'am. Yes, ma'am.
Yes, she is correct. It's thermal diffusivity. Thermal diffusivity is the ratio of thermal conductivity to the product volumetric heat capacity, which is the multiplication of density into the specific heat. So thermal diffusivity is equals to thermal conductivity into divide by density into specific heat. So this is the product's volumetric heat capacity. And the dielectric constant is basically the material's ability to store electrical energy, whereas the loss factor, it is the ability to dissipate the electrical energy in the form of heat. And temperature gradient, it means that there is a variation in the temperature across a medium, where there is like some point at higher temperature and one region is at the lower temperature. So option C is correct. So we are moving to the next question about the factors which does not affect the power absorption. Does not affect power absorbed in the food when there is a microwave heating. Frequency, electrical field strength, both frequency and electrical field strength, and the temperature. So what is the formula for power absorbed? P equals to
D.
the temperature. What is the formula for power absorption?
It is P is equal to 55.61 plus 10 raised to power minus 14. Then frequency into E square E dash. E square is electrical field strength, I guess, and E dash loss tangent.
Hmm.
Hmm.
Are we agreeing to her? She is correct. It's temperature, because the formula, as she rightly mentioned, this is our formula for power calculation. So our food, when like the power absorbed in our food depends on frequency, electrical field strength, loss tangent, and dielectric constant. But there is no temperature term in this formula. So option D. Is it clear that, like the previous question, was that clear for everyone?
Yes, ma'am.
So we have today 51 students. PDFs to our mail. I am already uploading these slides on the Google Drive link, so you can access from there. Kishore, Kunal. So please
Yes, ma'am.
access, yes, please access from the Google Drive. So you all, I think it's accessible for everyone, right? If I'm not
Yes,
wrong,
ma'am.
it's accessible.
Yes,
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 yes. So
yes.
please access from there.
Yes, ma'am.
Okay, ma'am.
So yes, which of the following statement about radio frequency and microwave heating are true? The radio frequency operating principle is same as microwave heating, but the operating frequency in radio frequency is higher. In radio frequency, the thickness of the food is restricted by the distance between the capacitor plates, and the radio frequency energy can be used to heat or evaporate moisture from the product. So we need to tell about true statement.
C, 1 and 3.
1 and 3.
1 and 3.
1 and 3. Okay. Please read carefully and let me know. So let's see. It's answer B. No, B answer is correct. 2 and 3, not 1 and 3. So let's see why this is so. So this is our radio frequency setup, right? Where there are electrodes, like there is a source for RF power, radio frequency power, and there are electrodes, and between this we have our food where there is oscillating electric field, and uh, we treat the food product like this. What happens in the radio frequency? The frequency it is having 1 megahertz to 300 megahertz, whereas in microwave it's 300 megahertz to 300 gigahertz. So one thing we can note from here clearly, that microwave is having more frequency than radio frequency. So option A is saying, but the operating frequency is in RF is higher. But what we have just now saw, that microwave is having the higher frequency. So option A cannot correct. It's wrong. So also the radio frequency and the microwave, they are both non-ionizing radiation because they have insufficient energy, around less than 10 electron volt, to ionize any biological any biological atoms. Radio frequency heating, it involves the transfer of electromagnetic energy directly into the food product, where there is a volumetric heating due to frictional interaction between the molecules, because alternating electric field is there, and because of that atoms align, and because there will be friction force generation, and because of this friction force there is internal heating of the food. So radio frequency heating, we also known this by high frequency dielectric heating. During this process, the food is heated to form, for the food to be heated, it forms a dielectric between the two metal capacitor plates. So in this diagram, we have this metal capacitor plate, and this is metal capacitor plate. Here it's food, which is acting as a dielectric. So these plates, they have the positive and the negative charge, and they are alternating charge, which are alternatively charged positively and negatively by a high frequency alternating electric field. So we have here the electric power. So this power is giving to the radio it is making like from the source radio frequency power, and this is the capacitor plates, which is having like alternating field, positive negative, negative positive, like that it will change. So because of this, what will happen, the polar molecules like the water, they will try to align themselves, and because of the polarity there will be the electric field. Since the polarity changes so rapidly, like we know that there are like, even if the range of the radio frequency is 1 megahertz to 300 megahertz, but there are like mostly the radio frequency and the microwave frequency, they are used for the communication purpose. So there are like a fixed frequencies which are assigned to or like to assign to this purpose, like the medical domestic purposes or like scientific industrial purposes. So the few few only few frequencies are allotted to this. And uh, because we apply the radio frequency to the food around like 27 megahertz, so we are taking 27 megahertz uh, as its frequency. So since the polarity it is changing 27 megahertz, that means it is changing 27 million times in 1 second. So if it's changing so fast, so what will going to happen? The molecules, they will try to like continuously realign themselves with the electric field. And since they will try to realign, because of that there will be formation of the kinetic energy and the friction because of the collision of the neighboring molecules, which generates the heat, and that's why the product is getting heated in the radio frequency. And like we said, that radio frequency operating principle is same as the microwave heating, which is saying in the option first that its operating principle is same. So first part is correct, but the second is saying the operating frequency in the radio frequency is lower, which is 27 megahertz, compared to the microwave, which is 2450 megahertz. So option first is anyway not correct. So the second option is saying in the radio frequency, that in the radio frequency the thickness of the food is restricted by the distance between the capacitor plates. So it is correct, because we can see in the diagram we have these capacitor plates and in between we put food product. So obviously the thickness should be restricted, which can fit inside this. So this option second is correct. Option C is saying that the radio frequency energy can be used to heat or evaporate moisture from the food product. So we have the internal heat. So because of the heat, the moisture will going to evaporate. So option 3 is also correct. So we have option B as correct. Is it okay?
Okay.
Okay, thank you.
Okay.
So let's move to this question, which is about in column first, we have different components like we have the electrode, cathode tube, waveguide and yoke. And we have different equipments like HPP, microwave, radio frequency and irradiation. So which part is matching to which? So electrode is there in
Radio frequency heating.
Option C. One is electrode radioactive frequency. Option A is correct, ma'am.
okay, option A is correct.
Yes, ma'am.
So first is you are saying radio frequency heating. Cathode tube is irradiation.
Irradiation.
Yes, ma'am.
3 is B and
Microwave
yoke is
high
HPP.
pressure processing. Yes, ma'am.
So you are correct. Let's see, like what is from this we have like I am having one doubt that okay, electrode we can like we can see in this that in that radio frequency heating, this system, it is having electrodes here and here. Okay, so I can match first to third. Okay, no problem. Cathode tube, we have just now see the X-rays, and this it is having this like cathode and anode system. So I can say, okay, cathode tube. Waveguide we have seen in the already we discussed about the diagram of this microwave. So yeah, so I know that microwave is having waveguide. But what is yoke? Waveguide, this microwave. Okay, but what is yoke? I've like when we were discussing the HPP, in the HPP equipment, what is yoke? Where it locates in the diagram? What is its
It's on
function?
top.
Yes, top. What
So
it
on
does
top
actually?
it supports to withstand the high pressure.
Mm. So it's like basically steel, like the many layers of the steel, which holds the whole vessel and bears the high pressure. Like this, we can see this is yoke in this diagram. This is yoke. Okay. So is it clear to everyone? Can we move to next question? Till now, if you have doubt, please ask.
Okay.
Okay. So let's see about some questions regarding supercritical fluid, which is our last topic. So what characteristics of the supercritical fluid are similar to those of liquids? So we know that supercritical fluid somewhere lies here in this region. So we have density and diffusivity, solvent power and density, viscosity and density, solvent power and viscosity. After this critical point where there is a critical temperature and some pressure, we have this supercritical fluid state.
Option A.
A, B, okay, B is correct. So we know when there is a pressure and temperature, some of a substance, when it raised above its critical pressure and temperature, the critical point we have just now seen in the diagram, then it enters the supercritical state. So supercritical fluids, they are basically highly compressed gases which have the property of both gases and liquids. Also, the fluids like the xenon, ethane, carbon dioxide, they offer the range of unusual chemical possibilities, and they are the basically supercritical fluids. So they are now used in different synthetic and analytical chemistry processes. So supercritical fluids, they have basically density and solvent power similar to the liquids, but the viscosity and the diffusivity is similar to the gases. So option B is correct. What is the solvent power? Solvent power means, because diffusivity we just discussed now. What is diffusivity? And then density we know, mass by volume. Viscosity we already know. Viscous, how much viscous is the fluid. And solvent power is solvent's ability to interact with other molecules, which leads to the dissolution of other substances. So option B is correct because it is having this characteristic as liquid, and the viscosity and the diffusivity, which is our no option in this. So viscosity and diffusivity as Okay.
Yes, ma'am.
So let's discuss this question that we have the decaffeination of coffee using the supercritical fluid extraction method. So what pressure and temperature we need for that? So we need a pressure of 300 bars and 40-degree temperature for decaffeination of coffee when we do in the supercritical fluid extraction system. So this is a theoretical question. This is the next question. So let's discuss this. Identify the incorrect statement with respect to the supercritical fluid extraction technology. Viscosity of the supercritical fluid CO2 is significantly higher than the viscosity of liquid hexane. Addition of a small amount of co-solvent increases the ability of supercritical CO2 to dissolve polar compounds by significantly changing its density and compressibility. Supercritical fluid extraction is suitable for extraction and purification of low volatile compounds. And last is the energy cost of the supercritical fluid extraction are lower than that of the traditional solvent extraction methods. We need to find incorrect statements.
D.
Option
C.
D.
C and D. Anyone would like to contribute with any of thing, like maybe with logics or maybe with answer? So option A is correct. Megapascal, sorry, millipascal second. So uh, it is significantly lower than the viscosity of the liquid hexane, where it is 3. It's 3, it's 0.5. So it's the option A is saying viscosity of the supercritical fluid CO2 is higher than the liquid hexane. But whereas if we see its viscosity is lower than hexane. So option A is incorrect. Then we have option B. So a small amount of the co-solvent when we use, so there is an addition when is this of the small solvent. So what it does is it increases the ability of supercritical CO2 to dissolve the polar compounds without significantly changing its density and compressibility. So which is correct, which is also like it says it increases the ability of supercritical CO2 to dissolve polar compounds, which is true, by significantly changing its density and compressibility. Whereas without significantly changing. So option second is also not correct. Then third is saying supercritical fluid extraction is basically suitable for extraction and purification of low volatile compounds, which is true. So this is true. And option fourth is energy cost is they are lower in supercritical fluid extraction than the traditional solvent extraction methods, which is also true. So option A and second is not correct. Like what happens, the main mechanism in the supercritical fluid extraction is the high pressure liquid CO2. It will come in the, and it how what it will do, it diffuses in the matrix, it diffuses the matrix, and it dissolves and resolves analyte from the matrix. So it will go interact with the whole matrix, and whatever is the analyte will, it will take like it will bind with that and it will take it out, and after that the supercritical CO2 plus dissolved analyte, they'll come out, and this CO2 it will be like it will evaporate, and only analyte which we need, it will, we can extract it like this. So this is the main mechanism of supercritical fluid extraction. And is this question clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So today we have discussed about food irradiations, like the ionizing irradiations, radiation stabilization of foods, and then different how it affects that radiation, like interact with different food constituents. And then we discussed about the microwave heating, and there are like the different factors microwave which affect microwave heating, and we discussed about its system and different machine parts. We also solved the question regarding penetration depth, and then we discussed about radio frequency drying and its principle and its system, and lastly we discussed about supercritical fluid extraction. We discussed about what is supercritical fluid, and then we discussed some basic concept. Oh, and for next week we are taking freeze drying, food extrusion technology, textured vegetable protein. So these will be our next week topic. Is there any doubt in today, like any other problem you want to share? Anyone? So this is my YouTube channel link. There I am posting all the, you can find all the week's videos, and the Google Drive link, which like we were telling that PDF you need. So please go through this Google Drive link. All the week's PDFs are already available. And this is my email ID. Please, you can write to me. So thank you so much for joining today's session. And tomorrow, like the next Sunday, we will have our session on the same time. Please try to join. Thank you so much for connecting. And if you have doubt, please ask.
Thank you, ma'am.
Okay.
Thank
Thank you so much.
Thank you so much, ma'am.
Thank you, ma'am.
Thank you.
Thank you.
Thank you.
Thank you so much.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
How to join discussion forum. So Ariti Kulkarni, aren't you there in the discussion forum? Like it's already, it's from NPTEL side. They only like they only make the group and included us also. So aren't you there?
No, ma'am, I'm not there.
So What is like? Can you
I'm
share
also
your
not there, ma'am.
details? You people are not there because it's very important. All the discussion and all the there on like it goes there only. So can you write an email to NPTEL that you aren't there, because it's really very important.
Okay.
Yeah. Also, if you want me also to, uh, ma'am, I am in the library. Yeah, me also to either any of your friend can message, like put a message there to add you, or I can also put, if I know the details about your enrollment, your name, your email ID, so I can help you with that.
Can I
So you
type it
can,
out right now? Yeah.
yeah, in the chat box.
Okay.
Yeah. Are you registered for the examination?
Yes, sir.
Yes, you should be there then in that group, because we regularly discuss even the many concepts also we discuss there, like the forming and about HPP treatment, how it denatured the food. We discuss many concepts there as well. So please, you message, ma'am, I'm in the library, I can't ask here, so I have a doubt what is co-solvent. Okay, so today's session is over, but I am going to either discuss about co-solvent in the next week, or if possible, I'll put co-solvent in the like, I'm sorry, I've seen your message lately. So I'll put in the discussion forum. So Alok, is it okay?
हेलो मैम।
Yes.
मैम एक्चुअली ये डिस्कशन फोरम जो हम लोगों का पास ईमेल आया था ना, वही तो है ना डिस्कशन फोरम?
हाँ, जहाँ हम लोग डिस्कस करते हैं ना, we discussed about many questions there, right? Have you seen that? Those, like, I show you. Maybe it's open in my, maybe. No, it's not open. Maybe I can see. This is, I think, this is, yes. So we have this kind of discussion forum. Are you guys all there?
No
No,
ma'am, I
ma'am.
am
I
not there.
received the email. Yeah.
How to join, ma'am?
Ma'am, I am not there.
Okay. So like this, we have discussion forum where we have so many, like, bleaching about it, so many questions. So what you can do is, maybe you can just type your your email ID, name, and enrollment number. So in the chat box, so we can add you. I will message, and maybe if it's possible, can I share the no, this is not possible. Okay, so you please give me your email ID information so that I can add you.
We have added
I
some email ID in the chat
I
box.
am given, ma'am. Please add this.
Preeti, I have messaged for you already. Have you also put an email? Preeti Verma, I have already put a message on discussion forum there. Like,
See, ma'am. Didn't see my name.